Welcome everyone to our second Computing Education Research Seminar of 2026, hosted by the Raspberry Pi Foundation. I'm Jane Waite and I'll be chairing the session today. In our seminar series this year, we're focusing on applied AI, and we are exploring research that examines how best to teach and learn about AI across the curriculum. But instead of focusing on research done just in computer science, we're also looking at research that is done in other disciplines, including the arts, sciences, and humanities. And very much today, we're looking at that intersection as we welcome Rebecca Fiebrink from the University of the Arts London. I have to say I'm very excited about this seminar, this particular presentation. I think it's going to be incredibly interesting, and we're very grateful to Rebecca for presenting for us today. I am very, very pleased to welcome today's speaker. That's Rebecca Fiebrink. She is a professor of creative computing at the University of Arts London. Oh, what she hasn't taught about creative machine learning, I don't know, but she's taught about this subject to university students, to professional artists, to members of the public, and to children for over a decade. And I bet it's longer than that. She has launched the world's first online course on creative machine learning and co-developed widely used open source tools. And in today's session, Rebecca will explore how and why we might teach AI for creative practitioners, including children, students, and professionals. And she will highlight this kind of broader creative potential of AI, which is just beyond that text to media kind of systems, demonstrating tools and approaches that support learning and enable new and accessible forms of creative practice across art, music, games, and design. So we're here very excited to have Rebecca with us today and to share her research. So over to you, Rebecca.
Thank you again for being here. I'm going to be talking about teaching AI to creators. And it's a wild time, of course, in creative AI right now. I've been in this space for nearly 20 years. And suddenly we went from nobody really knowing how AI could be used in creative work to everybody thinking that creative AI looks like what we have on screen, where it's just a matter of typing in some text and immediately getting a, feasibly human created pop song or a really flashy digital image of some sort. And I don't want to knock these systems. I think there are really interesting creative and educational uses of these kinds of tools. However, one of the things that I emphasize to my students, which I'm going to emphasize to you today, is that AI in creative work can be and already is so much more than these types of systems and these types of interactions. So I've been doing work in this area again for a long time, and I think it's useful, again, with my students and with you to emphasize that, you know, AI today is really just machine learning, and machine learning is really just a set of computational tools for finding patterns in data and for using these patterns to make predictions or to generate new data. And I've been working in this space since around 2008. Some key questions which I'm interested in, which I'm going to talk through with you today, include these. How can machine learning, which again, let's just call it finding and using patterns in data, be of value to musicians, to artists, and to other creators? What should machine learning tools for creators look like? And what do creators need to know about machine learning to use it effectively? And how can we teach them? I'm just going to touch the surface of these, but hopefully give you a nice overview and some new ways of thinking about creative machine learning and human learning. All right, so let's start with these first two questions. How can machine learning be of value to musicians and artists and other creators? And what might tools for them look like? I'll talk about these together. I've got four major points to talk through. I'm going to go through them in order. And the first one is this, and this is really what got me into this field in the first place, but it's not what kept me there. So machine learning, especially before a few years ago, where suddenly everybody was talking about generative AI and ChatGPT and so on, machine learning has been around for a long time, and it's been used in industry, in all sorts of research, and all sorts of other fields for a long time, primarily because it can be so effective in helping people work with data that matters to them, right? And this is true for creators as well. I got into this space because I was working with musicians who had all sorts of interesting things they wanted to do with sensors, with cameras, with microphones. There's all sorts of new types of instruments or performance interactions that people can make with these things. Same goes for the games space, right? If you can take information about what somebody is doing, how they're moving, and turn that into effective control over a video game, that's exciting. All sorts of interactive art, the same thing goes, right? So this was true back in 2008 when I started this. It's even more true today. We have potential sources of interesting, useful data all around us, and we can do so many creative things with this data, right? Data from Arduino, from microbit, from cameras and microphones, from smartwatches, from custom sensors like the Leap Motion. Also data that people have, in their creative workflows already, things like audio files or video files. Getting this data is increasingly really easy. We've got nice APIs, we've got nice examples, we've got nice tools. However, without machine learning, interpreting and using this data is hard, even for people who are experts at programming and even for people who are experts at signal processing, because a lot of this data is high dimensional. A lot of it's noisy. A lot of it is just really complicated to look at and try to say anything meaningful about what's happening in it. So machine learning is a really nice fit to working with all sorts of these types of data. And when I came into this space, again, I was really interested in working with musicians, many of whom wanted to build new musical instruments, where they really wanted data about what a person was doing, maybe sensed with sensors or coming in through a webcam. And they wanted to build a predictive model of what is that person trying to play? What kind of sounds do they want to make? Or in other cases, people were interested in getting data about what an acoustic musician might be playing live and then translating that into live control over visuals or lights or so on. Similarly, I had some early collaborators in the game space who wanted to look at how people might be moving or what they might be doing and turn that into control over a game engine. Now, all of these are pretty nice setups for the kind of predictive machine learning we do when we do supervised learning, right? So we can think about supervised learning algorithms as a set of techniques for building predictive models. And here, if we're making a musical instrument, this model might look at data from how somebody's moving, sensed with sensors or a camera, and it's going to predict what sound does that musician want to play based on how they're moving, right? And lots of times in creative practice, whether you're making musical instruments or interactive art pieces or games, these models are things that people build by writing code, right? Somebody's going to type out a function or they're going to drag blocks around in some sort of visual programming environment that say, hey, here's some rules that say how to make this prediction based on the data that we see. Of course, when we're using high dimensional sensors, we've got real-time data, we've got noisy data, this becomes really hard, as I mentioned. So building this model instead with a supervised learning algorithm can just be a really nice alternative. And we're going to build this model from some training data. And in supervised learning, this training data looks like a set of examples here of the thing that's going into the model and the thing that's coming out. So if I'm building a new musical instrument, I'm going to give my algorithm examples of, hey, here's an example movement that I'm going to do paired with the sound that I want to be created when I make that movement. All right. So I started working on this when I was a PhD student and was really surprised that actually, even though machine learning was well understood to be valuable for these kinds of signal analysis and prediction tasks, almost nobody in music, almost nobody in interactive art was using it. And initially, I thought, well, maybe this is because we just don't have really user-friendly interfaces, and people are asked to know a lot about machine learning and a lot about programming in order to use machine learning. And that was sort of true, but actually, I learned pretty early on that making this process accessible to creators required more than just a friendly GUI that you stick on top of the learning algorithm. Specifically, there are a few really interesting, important differences when you want to use machine learning to take advantage of this sort of data in creative contexts, like making an instrument or making an interactive game. The first is that There probably isn't an example training set hanging around that you can just model, right? And if there were, it probably wouldn't be the right training set for you because you probably have a really novel idea of the relationship between maybe gesture and sound or gesture and gameplay that you want the model to learn. So when I started building a piece of software to allow creators to use this kind of machine learning, the first thing that it did differently was allow people to demonstrate these gestures and sounds or actions and computer predictions to demonstrate them in real time. The second thing that's different, often in these contexts, is that just running sort of conventional metrics on these models that compute accuracy on some held out test data, that's not going to be enough, right? If I tell you, oh, the model that you made is 95% accurate in predicting what sound you want, what does that even mean, right? Is that model going to be good enough to use in a musical performance? Depends entirely on what kind of mistakes it makes. Maybe I can avoid those mistakes, or maybe those are gestures that are really important to like the dramatic beginning of my piece. So Wekinator, the software I built, allows you to test out the model in real time by moving around and seeing what happens. The third thing that Wekinator allows you to do, which is kind of breaking the rules of how you would normally do machine learning in more conventional applications, is it allows you to go back and edit the training data. If you don't like what the model does, don't change your neural network architecture. Don't, first thing you can do is say, no, I'm going to change the examples. So if I'm trying to get it to react to hand positions and it doesn't accurately predict when my hand is maybe a little tilted, I can go back and give it examples of the thing it got wrong, of my hand being tilted. Or if I want to make my model more complicated, I could add an entirely new gesture with new sounds, and I can repeat this process over and over until I am happy with the model. And so this set of interactions, demonstrating training examples, trying out a model in real time and seeing what happens, and then going back to modify the training examples, this is all called interactive machine learning. And it's approach used in Wekinator since 2008, but also in a number of tools since then. So to make this really concrete, I'm going to show you a demo. And this is a pre-recorded video because Zoom does not like live demos. So I'll just show you the video now.
All right, in this demo, I'm going to build a very simple gesture-controlled drum machine using Wekinator. As my input device to capture information about gesture, I'm going to use my webcam. And I've got a little program here, which I like to call the world's worst computer vision feature extractor. What I'm doing is just taking those pixels coming in from the webcam and downsampling that to a 10 by 10 grid of color values. And this gives me 100 numbers, and these numbers are going to change as I move in front of the camera, as you see. But even if you're an amazing programmer, I would guess that you would not want the job of writing the program that looks at these 100 values and says something useful about what I am doing in front of the camera. So instead, we're going to use machine learning to make sense of these 100 values and make pretty accurate predictions about what kinds of gestures or motions I'm doing. All right, so I'm going to have Wekinator here listen to 100 values from this camera program, and I'm going to build a classifier, which is going to, again, predict what type of action am I doing at the moment. And we're not going to load a training set from somewhere else. We're actually going to build this training set right from scratch in the demo. And I want to, not just have Wekinator output a number. I want to have this control a sound and make this a little bit fun, right? We're going to control a drum machine, like I said. So I'm going to run a very simple drum machine program written in Chuck. And when I send this drum machine different numbers, we're going to hear different sounds, just like this. All right, so let's start out. Let's give it some training examples. And I'm going to say that when I am right here in front of the camera, I want to hear this simple sound. So I've got 17 snapshots of me here paired with this sound. And next I'm going to tell it that when I'm not in front of the camera, turn that down so you can hear. When I'm not in front of the camera, when I'm out of frame, I want to play a different sound, specifically this one. Let's go. Okay, now I've trained, I've built my model. Let's run this model and see what happens. Okay, it's pretty good. It's definitely changing between the two sounds, more or less the way I'd like it to. However, it's being a little bit too eager to change to that second sound, even when I'm not totally out of frame yet. So I'm going to give it some more training examples to try to fix that error and say that when I'm right here, actually I still want to hear the first sound. And now I'll retrain, I'll rebuild that model, and we'll see if it works any better. And in fact, that's pretty good. I can keep moving around and see if I can make it make other mistakes, like right here. I can, oops, forget I did that. Let's give this as sound 1 and say that I want sound 1 over here. And I can retrain and keep running and see that, yes, it's doing what I'd like. And once I'm happy with that, maybe I want to make it more complicated. I could give it another sound with, say, my hand in front of the camera, like this. Okay, there we go. That is a pretty easy way of using Wekinator to make a classifier where I'm controlling a few different sounds based on simple movements of my body.
Right, so hopefully that was a helpful demo. As I mentioned, I began building that in 2008. It's been immensely popular. It's had over 50,000 users, just the most recent version of the software. I used Wekinator in the world's first MOOC on machine learning for musicians and artists, which was on Cadenze. I've used it in artist workshops worldwide at places like Barbican, BBC, Radio 1 Academy. And it's used by people other than me at a lot of universities and creative coding institutes around the world. I'm going to show you a few examples of creative work that's been made with this. This is one of the first musical pieces that somebody made. This is an instrument that's created using an old PlayStation golf game controller. And so here you have sort of a two almost like 3D joysticks that you can move with your hands, and it measures X and Y position and sort of the length of this string that gets pulled out. And I want you to, as you watch this, think about the difference in making this kind of interaction with programming versus making it from examples, right? So the composer here had a very particular vision for how she wanted the performers to move over time and how she wanted the sound to unfold over time. And even though this is a relatively low-dimensional, non-noisy controller, you can imagine what a programming challenge this would be, even for somebody who is an expert. So this is a quick clip of Anne Haggis from The Waters. Another really early musical instrument made with Wekinator was Michelle Nagai's martlet. I'm not going to play a video of this, but you can find more online if you're interested. This is a piece of tree bark, and she embedded 25 light sensors into this tree bark, attached them to an Arduino, which sent the light sensor data to Wekinator. And she plays this instrument by casting shadows over the bark with her hands and leaning into and away from the light. And it's really beautiful. And the complexity here, this is starting to get to the point where this is really hard, if not impossible, to make into a viable instrument, a performative interaction that plays music that you're happy about, unless you use some kind of machine learning that works from examples. People in the art space started using Wekinator fairly early on as well. This is an early art piece in which you wear a little camera on your head, which sends data to Wekinator, which builds a classifier that determines whether or not you're looking at a screen. So is there a phone or a TV or a laptop in your field of vision? If so, it sends a signal to these special glasses, which become opaque. So you can't actually look at screens while wearing this art piece, which I think is really fun. The last example I'll show you with Wekinator here is Highbot. Here we've got a little leap motion, which gets finger joint position from the hand. And here we have Wekinator determining whether or not somebody is waving. And if you wave, Highbot waves back. There's just a little Arduino with a servo motor behind the cardboard. And this is all Highbot does. And so this is something that you absolutely could build with a fair amount of experimentation, a little bit of math knowledge, a little bit of programming, but boy, is it faster to build with machine learning, where you can just demonstrate what a wave looks like and not try to sit down and figure it out in math. Because of the success of the Wekinator tool, I had a lot of interest in collaborators wanting to make similar tools for slightly different domains. So for instance, my team made a tool called Mimic, which is available online for teaching creative coding online. And it has a bunch of interactive machine learning tools you could just play with without even downloading anything. And then you can kind of write some JavaScript code to say what those models do. InteractML is a tool that my collaborators and I released a few years ago for working in Unity and Unreal, so people developing games and virtual reality experiences. And I'll talk in a few minutes about the Sound Control project, which is a really simplified, streamlined interface for building musical interactions. And this is specifically for kids, music teachers, and therapists. Other people have also taken up the interactive machine learning style approach that Wekinator pioneered. You can see it in Google's Teachable Machine, which I'm sure many of you have tried. It's now in the new Microbit Create AI tools. And if you're an Ariana Grande fan, you may have seen her using a special glove on tour a few years ago. She used the Mimu glove to do live vocal processing. And this glove actually uses the same interactive machine learning workflow as Wekinator to allow you to train it to recognize your own hand positions. All right, so the first point that I shared with you, I really went into detail about how machine learning can help creators work with data that they care about. As I said, this was my motivation to get into this field because I thought, oh, everybody has interesting data analysis challenges, and if we could just help them solve those, we would allow them to do interesting things. And that's absolutely true. But a lot of my work over the last 15 years or so, more than that now, has also been discovering and exploring some of the other benefits of machine learning. And one of them is this, that machine learning allows people to communicate their ideas and their intentions to computers through the use of data and examples, as opposed to programming or math or even natural language. And this is really powerful in a lot of types of creative practice. So if we think about Michelle Nagai's Martlet, for instance, she's communicating through her examples, hey, what does it look like for me to cast shadows over the tree bark with my hands? What does it look like for me to do a move that looks like a very, subtle, delicate sound or a really dramatic big sound? This isn't just the case for supervised learning. This is also true and really powerful when it comes to generative machine learning. So this is an example from Memo Atkin. He's a really fantastic artist, digital artist, who's done some groundbreaking work with machine learning. This is a piece from 2019, which is, of course, ancient in machine learning terms, but this is the first interactive video work that anybody anywhere did, as far as I know. And what you see on the left is the input to his webcam. So he's just moving stuff from his house along, in front of his webcam. On the right, you see a generative machine learning model trying to recreate the scene that it sees on the left, except that this model has only been trained on images of the ocean. And so no matter what he does, you're going to see these lovely seascapes on the right side. Later on, I can show you another model. This is trained only on images of fire. And so again, he's able to manipulate these fire images just by moving stuff around in front of his webcam. And here's another model that's only trained on flowers. So again, here, Memo is using these training sets to communicate very precisely to the machine what kind of visual scope is allowable in this interactive piece, right? What is his aesthetic world? And of course, he's trained these models himself on a fairly small number of visual examples. And so he's able to exercise quite a lot of control over what the model does as a result. Another example from work in the music space with generative machine learning. This is a project called RVAE. This is by a postdoc of mine called Gabriele Viglinsoni. And this is a generative music model that uses a very simple sound representation. You only need a few dozen training examples as opposed to millions, which is the norm in music models these days. And what he's doing is building an interface that allows him to create variations on a set of rhythms that he's composed or that he's curated. And you have this 2D interface, which you could use by moving your mouse around, and it's going to create different rhythms as you move through the space. And we play a short video. It is a little bit flashy, so if you're sensitive to flashing lights, don't look at the screen for the next little bit. All right. Now, if we think about training examples as a way to communicate very precisely and effectively to machines what it is that we want aesthetically in some kind of creative practice, there's another really insignificant benefit to this, which is that when we are trying to communicate something where we have tacit knowledge or embodied practices, these are especially difficult to communicate using math, using code, or using even our own native language. It's much easier if we demonstrate, hey, this is how I want to do things, or this is how I want to move, or this is how I want something to sound. This is how we communicate with each other as people when we're doing many different types of creative work. And when we're using machine learning and training models on our own examples, actually, this is extremely powerful. All right, the third point I want to share around why machine learning is useful for creators is that designing with machine learning can enable more people to engage in the creative process. This is part of the narrative that we're seeing right now around, sort of industrial Silicon Valley machine learning. The idea being that, hey, if we've got these large one-size-fits-all models trained on lots and lots of data, these make it easier for somebody who's an untrained novice to conform to some standards. So anybody can click on the screen and write music like Bach, or do something in Microsoft Paint and then turn it into an image like Monet, or maybe make a video that looks like Wes Anderson. And these are fun. Some of these really fun, and I think they do have some educational applications, but this is just the tip of the iceberg, right? A lot of my work has explored how allowing people to train their own models with new data, maybe data that they've created or that they've curated, this is a really fantastic way to allow them to personalize computer outputs, whether we're doing supervised learning or generative machine learning. This allows them a lot of flexibility in what the computer might do. It doesn't force them to make music or art that somebody else has made, right? And they're not mimicking people anymore. And this is something that I've explored a lot in collaborations with people with disabilities. And so we have an early CHI 2015 paper about the Sound Lab project, and a more recent paper about a project called Sound Control. This was a collaboration with music teachers and therapists who are working with kids with a really wide array of disabilities. And something that was, for me, really exciting about this project is that even though my collaborators came to me at the beginning and said, hey, we've seen Wekinator, we want to have the ability to build instruments for the kids we work with. That was great. We built them some software, which is, does what Wekinator does in a more streamlined, easy to use way. And they did build some instruments, but it was super exciting for me that that's not all they did, right? As soon as they had control over the software themselves, they built models to do all sorts of other things. They made games, they made improvisation interfaces. And actually, because a lot of these kids were primary school kids, including my own children, they really love fart sounds. And one of the things the kids really wanted was new ways to control fart sounds. So that's one of the things that they ended up doing. And we actually gave them like a fart sound Creative Commons library to use in the tool. So I think this is a great example of how giving people the ability to make things for themselves, including training models for themselves, allows them to do so much more and to make more useful outcomes that wouldn't be anticipated even by experts who aren't sitting there in the room with them, making things and experimenting with them. Sometimes I do want to mention helping novices conform to a standard can facilitate other creative tasks. So one other project I want to talk about briefly is called the Imagination Tool. This was published a couple of years ago with some collaborators, including folks from a London design studio who work with kids. And they were really interested in saying, hey, how could we use generative AI in the context of ideation and futures thinking by children, right? Right now, we're doing all sorts of workshops where we get them to think about, say, the futures that they want, and then they might draw it with some markers on a piece of paper. But what might change if we gave them the ability to make really polished pictures or to make, pictures that are legible to people over the age of like 10? So we built this generative AI-based tool for them. We did a lot of work to try to make it usable for kids with, helping them with prompting, using, voice to text for people who couldn't type, all sorts of stuff that's in the paper. But here, the idea wasn't that, oh, we're going to help people make art by giving them text to art interfaces, but really exploring, hey, how might it matter if we allow people to make more polished looking art in the context or more polished looking visuals in the context of ideation, brainstorming, futures thinking, and communication? All right, the last point I want to share about why machine learning is useful for creators is this, that machine learning can enable really exciting new types of creative work. I've already shown you a few examples of new instruments people have built with Wekinator. Here's a few other examples. Chicks on Speed is a well-known experimental music group who've made some really cool, like high fashion footwear controllers that allow them to control live performance parameters as they dance and move on stage. Mariah Ballman is an experimental musician who's actually done work training and retraining machine learning live as part of her performance. We've got possibilities for all sorts of new interactions, including Memo Atkins' visual instrument here that I showed you. I've had students and other people using Wekinator for really bizarre, kind of fun things. One guy made like a self-charming snake system. This was from one of my students. Somebody on the internet built a controller where you could hold up different food and it would control Google Maps. You could like hold up croissant and it would take you to Paris, or hold up an espresso and it would take you to Milan. On the more serious end, some of my favorite artists are doing really innovative stuff. And these, Stephanie Dinkins, Holly Herndon, DataBots, these aren't people who, have used Wekinator in their work as far as I know, but I think they're really good examples of where professional creators are going and how they're experimenting with machine learning. So this piece by Stephanie Dinkins uses a generative text model that's trained on oral histories from women in her own family, from 3 generations of her family. She embedded this in this beautiful sculpture, and you can walk up to it and talk to it about her family and about this particular slice of African American history. Holly Herndon has done really interesting work, including releasing what you might call a deep fake model of her own voice and encouraging people to take her voice model and remix it and play with it and make new things with it. DataBots has made these really funny, sort of tongue-in-cheek, infinite live streams of genres like death metal or math rock, and you can find their streams online. All right, so I want to wrap up by talking a little bit about how I think about teaching machine learning to creators. I'll share some principles that I've developed over time in my work and some challenges. I would love to, go into much more detail of this, but I realize that we have a pretty diverse audience and people teaching at different levels. So I'll try to keep it high level and we can talk about it more maybe in the discussions. So first principle that I bring into my work is no matter who I'm teaching, I tend to teach machine learning at a high level with minimal math, but I don't teach about machine learning as a black box, right? So this is whether I'm working with kids or I'm working with master students who many of whom do have good math capability, I think the math is often not the most important thing, or even one of the top 10 most important things. At the same time, I don't think it serves anybody well to think about machine learning as this sort of magic, right? It's not magic. It's actually not that complicated. Um, and so if you look at the InteractML interface, for instance, what it does is it makes transparent things like data flow, right? Where's my data coming from? What kind of model am I using? Maybe I can visualize my data set and start to build intuition about what's in that data set and maybe diagnose when something's going wrong. I can also connect it to other things that I care about on the input and output side, right? So this is one example from one project, but I think a nice example of my approach to teaching. Happy to answer questions about that, of course. Second principle is that in all of my teaching, I do bring in practices around small data sets and interactive machine learning the way that you saw in Wekinator, right? There are a few really important benefits here. So number one, as you saw in the Wekinator demo, if you have a small data set, an appropriate tool, you can experiment really quickly, right? You can build a model in a few seconds, and then you can change the data and see how it changes the model. This is really helpful in building intuition about like how data quality affects your model quality, intuition about outliers, intuition about how different algorithms that may or may not do regularization might impact what is learnable. And of course, this is creatively useful. You don't necessarily need to just look at this as a toy approach. You can build really sophisticated musical instruments and creative interactions just with these kinds of tools. I also have built other tools that are complementary. I talk about these in a Transactions on Computing Education paper from 2019, where, for instance, you can click around on a screen and say, hey, if this is my training set, where might my decision boundaries be? Another benefit when we talk about building intuition about machine learning, one of the things that interactive approaches really foreground is that data is a choice, right? The data set that you make in these tools, this is literally you choosing what to demonstrate and changing that over time. But if you think about all the big data foundation models in tools like ChatGPT or Stable Diffusion, right? These are all also choices that people have made. That tends to be obscured in a lot of the ways that people talk about AI right now, but choices have been made about what is important to represent, what is not worth representing, right? How do we want the models to work, and how does the data reflect that? Likewise, bias in data, it can be really foregrounded in these types of interactive tools. In interactive machine learning, often you're intentionally inserting bias in your data because you want your model to do some things and not others. Again, data is your way of communicating what you want to the machine. Principle number 3, I really like building and using modular machine learning tools that allow customization and remixing when we're working in creative contexts. So Wekinator, for instance, doesn't know anything about sound, doesn't know anything about sensors. It just takes real-time data streams in from a protocol called Open Sound Control. Mimic, which I mentioned is the web tool, can do it from Open Sound Control or like WebSockets, right? Likewise, Wekinator can output data to kind of anything you want, to your favorite sound or music programming environment, to an animation environment, to a game engine, and so on. All right, so this gives people a lot of flexibility with a really core set of machine learning models. They can apply it to all sorts of different creative, unique applications. The sound control application, this is the one that I made with music teachers and therapists and kids with disabilities, also very modular, except that it's all self-contained. So here you can pick your input from a drop-down menu. You can pick what kind of sound control you want from another drop-down menu, and then you can also drop in your own samples to make your own sounds that way. Fourth principle is that many machine learning objectives can be, and I think often it's nice to do this, they can be framed in terms of the creative design process. So instead of saying, hey, we're going to organize things the way that machine learning textbook does, and we're going to talk about data representation and algorithms and what it means to make a good model, what it means to overfit, how you would evaluate a model in a training set, you can frame all the important stuff that one needs to know about machine learning in these kinds of creative contexts in terms of the design process instead. So this, again, I've talked about in my Transactions on Computing Education paper from 2019. I'm relying on a previous work from 2008, which talks about different operations that arise in both creative design as well as engineering. So if we're thinking about establishing design requirements or formulating a problem, actually, this aligns really nicely to understanding the structure of machine learning problems in general and what different algorithms are capable of, which is, a pretty important learning objective in all of my teaching. All right, I want to end with talking about a couple challenges. Something that probably you've encountered if you've thought at all about teaching in creative machine learning contexts is that the tools that are available commercially are not always great for scaffolding learning or for really genuine creative work, right? A lot of them look like this thing on the left, this is Suno. So it's like, hey, you get a text interface, you type some stuff in, and then it just looks like magic, and you have no insight, no transparency, and very little control beyond the text prompt. The closest, the alternative to that is something that's like thousands of lines of Python code, which is where most machine learning classes now are taught, most tutorials or textbooks kind of drop you in right at the beginning. And it'd be nice to have more options where there's sort of a middle ground. Of course, I think this is changing, especially in the space around learning. As I mentioned, Teachable Machine and the microbit tools fill that gap a little bit. They allow you a lot more control than something like text-based interfaces. My students over the last year have really found a lot of mileage with some node-based tools like Comfy UI, which is definitely worth checking out. Doesn't require you to do text-based programming, but still gives you a lot of flexibility and the ability to work from examples that other people have made. Second challenge is that if you're working with kids, wow, making generative AI tools that are safe for kids is incredibly difficult. And this is something that, again, we talk about in this ICCC paper from a few years ago. We started out by choosing a model that advertised itself as having a built-in safety feature or filter, but that was absolutely not enough. We had to do all sorts of work to, take the prompts that people were typing in and filter them according to bad word lists, safe word lists, do toxicity detection on the prompts. We had a human teacher in a moderation loop, ensuring that things were going to stay okay. We did a lot of prompt engineering in the background, in between what kids put in here and what actually was sent to the model. And we did all this extensive testing in advance. And currently, if you want to make a tool for kids, you've got to do all this yourself from scratch. And it would be so nice to have more community-driven efforts around this, because we know that kids are using AI. We know that there are legitimate uses for AI by kids, but it is so hard. And that's a big challenge right now. All right, so I've got some final remarks to share with you. First of all, learning and teaching creative machine learning is absolutely worth it. I've talked today about how machine learning can help creators work more effectively with data that they care about. I've talked about how machine learning allows people to communicate ideas and intentions to computers through examples. This is a very different way of working with computers compared to writing code or writing math. And this is especially relevant and helpful for embodied practices like we encounter in art, in music, in design, as well as in all sorts of things like, sports or daily life. Designing with data can enable more people to become creators. Sometimes, this looks like helping people who aren't professionally trained make stuff that looks really highly polished, but that's not the end of the story, right? It also means that when people build their models with their own data, they can do something totally new, and that's exciting. And of course, machine learning can enable great new types of creative work. And finally, learning and teaching creative machine learning is possible. We have a growing set of tools now that allows meaningful experimentation and very original creative work without any math or coding, or other tools that don't require much math or coding. So I've showed you my tools, Wekinator, Mimic, and InteractML. I've mentioned other tools like Teachable Machine, Microbits, Create AI, and Comfy UI. There are others like Plucoma and Touch Designer. The tool landscape is not perfect, but hey, we're coming along. And finally, creative applications can be a really fun jumping off point for broader engagement with machine learning. It can be so much more fun to say, hey, we're going to introduce you to ideas about bias in machine learning or about the ethics of how training sets might be agglomerated, right? By making some artwork or by making musical instruments. Hey, we're going to learn today about, what outliers are and how they might impact on machine learning by making a musical instrument or making an interactive art piece, right? It's a fun thing to do, kind of for anybody. But these can also be a meaningful destination in themselves, right? Because creative practice is one of the things that makes us human. It's one of the things that's enjoyable for just about everybody. And if we can have the right tools and the right teaching approach, then it can be really fun and rewarding. All right, so that's it from me. Thank you so much for listening to my talk.
Thank you for the most brilliant presentation. Can we give Rebecca a round of applause? Just in my own head, I'm kind of so excited about the ways that we can reveal underpinning ideas, but with these really abstract ways, abstract data items somehow, because I think a lot of the time we're constrained by our view of we've got to explain it with the math, we've got to explain it with that, but these are just so much more exciting ways to do it and more powerful, I think. Thank you to all of you for joining. Let's give Rebecca a big round of virtual applause. Please fill in our attendee survey. Bonnie has shared the link, I think, in the chat, because your feedback really is very, very important to us. Our next seminar will take place on Tuesday, the 14th of April, when we're hearing from Catherine Jensen-Eller, and she is a principal investigator at the National Science-Funded Data Science, AI and You in Healthcare programme. So we're moving into healthcare there. She's going to explore how to teach you to critically evaluate AI in this other kind of domain, which I think is really interesting, whilst they're also learning about data science and machine learning skills again. So if you'd like to find out more about our series, please kind of have a look on the website. Bonnie, I'm sure will share the link. And thank you again. And so if you want, you can turn your mics on and you can say goodbye.